This video is going to focus on our, how many did I give you guys? 1, 2, looks like 3. I gave you 3 series worksheets, and I told you I was going to swing the camera around so that we could use the whiteboard. All right, I lied. This first worksheet looks like this one. Obviously, you can see it up here. First worksheet I want to use the smartboard with, and then we'll get it swung over here, and I'll start drawing them on the whiteboard. We'll figure them out. So let's look at this first one. Now you guys know, and we've done this, series resistors are easy, parallel resistors are easy. When you get into series and parallel combinations, it gets difficult. So with series, remember, when you're trying to find total resistance, you are going to add your resistors up. So if you look at number 1, it says R1 is 10, R2 is 15, 3 is 20, 4 is 25, 5 is 30 ohms. And we add those up, what are you going to get? Well, you got 10, 15, there's 25, plus 25 is 50, plus another 50, total resistance, 100 ohms. Okay? Not as easy. What was the other key thing about series circuits? Remember I said what to remember when we're doing series? Oh yeah, current in series is always the same. Let me say that again. Current in a series circuit is always the same. Doesn't matter where you measure, right? Series circuit. It's Christmas lights. Oh, my phone is going off. So, if the current through R1 is 2 amps, how much current will flow through R2? Current in series is always the same. Question 3, how much current will flow through R3? How much current will flow through R4? How much current will flow through R5? 2 amps, 2 amps, 2 amps. Somebody is sending me messages right now. Phone keeps going off. Uh-oh, I swear it's not Corona. Okay, so we're down here to the actual table. Let's figure this out. Now, we already figured out if you add these 5 resistors up, you get 100 ohms. Right? You get 100 ohms. I'm wondering if this is the Teams app going off. Let's see if this is you guys getting a hold of me right now. Yep. I sent a message out to you guys. And, yeah, you guys are like blowing my phone up right now. So, it works. So, all right. So, again, in a series circuit, all the currents are the same. Remember, on series, you can, this says we have 2 amps and I1. Fill this all in. Fill that all in. Okay, now you're going to go back to your ohms and watts law stuff. So, how do you get a voltage? Voltages are always current times resistance, current times resistance, current times resistance. So, 2 times 10 is 20 volts. 2 times 15, 30 volts. 2 times 20, 40 volts. 2 times 25, 50 volts. 2 times 30, 60 volts. I don't know if you guys can hear this, but if I'm looking at this, I see, oh boy, I have a whole bunch of you guys checking in right now. I got messages from Trenton, Carlson, Sweeney. Yeah, I'm going to have to get back and tell you guys. So, all right, so how do we get our total voltage then? 2 times 100 gives us 200 volts. Okay, now remember Kirchhoff's voltage law. What was Kirchhoff's voltage law? The sum of the individual voltages. Yeah, this is going to be funny because I am not going to stop this video. I'm going to let this phone continue to go off. Sum of the individual voltages always equals the applied. So if you add up E1, E2, E3, E4, and E5, you get 200 volts. We did this right. The last column here is how do you get power? I'm almost wondering if people know I'm recording because this phone is going off so much. How do you get a power? I'm going to set the phone over here. So, you got E1 times I1 gives you P1. So all you got to do to get all of your powers is multiply your voltage and your currents. Okay, voltage times current. So if I do 20 times 2, I'm going to get 40 watts. 30 times 2, 60 watts. 40 times 2, 80 watts. 50 times 2, 100 watts. 60 times 2, 120 watts. 2 times 200, that is your 400 watts total. All your powers are going to add up to your total power. So is that kind of, hopefully that reminds people how to do these. So again, once you find one current, you found all your currents in a series circuit. This is not parallel. Remember, when we get the parallel, all your voltages are going to be the same. And again, you add up all your resistors, get your total resistance. Okay, we'll go to another one of these worksheets here, but I am going to put my phone on silent so that it quits going off. So we'll get right back to this. There it goes again. Okay, so this is the one we're going to work on. It's the paper that says Series R, number 1, page 2. Okay, so I'm going to swing the camera over here, and we'll do this one. It's the one that has 24 ohms, 48 ohms, 28 ohms, 150. Okay, so that's the one we're going to work on. So if you want to get that paper out, we'll do this problem. So if you're looking at that worksheet that says Series R, what's it say, number 1, page 2, this is my drawing. Okay, for it. This is the circuit that we're going to do. Again, make sure you get your calculator. So, first thing is, why don't I write down my actual resistances on here. What do we got? We got 24 ohms, right? Next one is 48 ohms, 28 ohms. We have a 100 ohm and a 50 ohm, correct? Okay, they're all in series, right? What do you do if they're in series? Add them up, get your total resistance. So if you add all these guys up, and all those up, you end up with, and you're going to write that on the RT, your paper, right? Total resistance equals 250 ohms. So that's your total resistance for this circuit. Okay? Now, what's the one piece of information from our worksheet that we have? We only have one piece of information. I mean, I can swing the camera around, or you can just look at your worksheet, and it says E1 is 96 volts. Okay? So that's the only piece of information we know. We know that this E1 is 96 volts. So how do we solve the whole rest of this circuit? Ohm's law, right? So if we know that E and we know an R, E divided by R is what? All right, so you guys are going to take 96 divided by 24, and you should get 4 amps. Okay, so if I divide those two, we will know the electrons flowing through this. Remember, current's flowing. We use the electron current flow, negative to positive. That's what we use in here. So we have 4 amps flowing through resistor 1. Well, how much is flowing through resistor 2? That's right, current in series is always the same, so R2. Or you're going to write on your paper I2. 4 amps. I3. 4 amps. I4. 4 amps. I5 is 4 amps. What's my total current then? Probably 4 amps, right? So that current's coming out of the negative terminal of the power supply. So you can write on your paper, IT is also 4 amps. All right? So if we know that little piece of information, we can probably finish this circuit, right? Because we know an I, we know current, we know resistance. And if you multiply current by resistance, you'll get voltage, right? Okay, so let me grab my calculator, because I don't have these memorized. So if we do 4 times 48, 4 times 48, we get 192 volts for this one. We do 4 times 28, 112 volts for this one. 4 times 100, I shouldn't need a calculator for that. 400 volts, 4 times 50, shouldn't need a calculator for that one, right? 200 volts. Okay, so Kirchhoff's voltage law is the sum of the individual voltages must equal the applied voltage, right? Your power supply has to add up to these 5 voltages. But there's another way we could also get this, isn't there? There's 2 ways to get this total voltage. We know total current, we know total resistance. Almost easier to do that. If you go through and do 4, right? Here's I times R, 4 times 250. You're going to get 1,000 volts right here. 1,000 volts. Or we could go through and say, oh, I'm going to add all that up. Yeah, okay, 1,000 volts. So we did this one right. Okay? So that's how you do the series ones. It really doesn't get any more complicated than that. I guess we could finish. I always do this with you guys. As you remember, I always make you do the powers on your own. Why don't we just do this one with powers, and we'll call this video good enough for series, because it is pretty easy, and you guys have all done this before. So, all right, let's go through and calculate power for this. How do you calculate power again? P equals I times Z. Okay, so P equals I times Z. I'm going to need a calculator. So here's our I. We got 4 amps, 96 volts. So if I do 96 times 4 equals, this one's going to have P1 is 384 watts. Okay, P2, do 4 times 192. So this one's 768 watts. That's P2. I'm going to do 4 times 112. 448 watts. P3, 4 times 400, 1,500 watts. P4, and 4 times 200, give me 800 watts for P5. So there's power, 1, 2, 3, 4, 5. How do I get my total power of my power supply? P equals I times Z, right? So you got 1,000 volts, 4 amps, means my total power, and that marker is dead. My total power should be 4,000 watts. So 4,000 watts for that one. Okay, so that's a refresher in series circuits. Hopefully my big head isn't in the way here. So that's series circuits again. Again, if you guys have any questions, get a hold of me on Microsoft Teams. And I have been hearing my phone over there. I moved it to the other room because it's still blowing up with you guys chatting. So, which is good. I'm glad you guys are using it. So, okay, we'll see you in the next video, which is going to be parallel circuits. So parallel circuits is next. So just remember, with series, your current's always the same. Your resistances are going to add up to your total resistance. And remember Kirchhoff's voltage law, the sum of the individual voltages must equal the applied voltage, which is your power supply. So, all right, see you guys next video.